In this lecture, we are going to explore one more function called useEffect. Let's talk about an issue with our project. JavaScript is not a language that persists across page refreshes. For example, I'm going to click on the link to increase the counter. After a few clicks, I'll refresh the page. The counter has been reset. Browsers will not store your functions or variables in their memory after the user navigates away from the page. This behavior can be beneficial for preventing memory leaks. However, we may need to persist data after a page refresh. In the resource section of this lecture, I provide a link to a documentation page for an API called local storage. The local storage API is available in most browsers. It's not specific to React. The purpose of the local storage API is to store data in the user's browser without an expiration date. Users can navigate away from a page or completely close their browser. Our data will continue to be stored in the browser. For this lecture, we are going to store the count in the local storage. If the user refreshes the page, we'll check the local storage for the count. To achieve this behavior, our data needs to be observed. It just so happens that React has a function for observing our data. Let's give it a try. Head back to the React project. We are going to continue working with the counter component. Our first step will be to watch the count variable. Above the handleClick function, let's run a function called react.useEffect. The useEffect function can be thought of as a spy. It's capable of observing our data for changes. It has two arguments. The first argument is a function. Let's pass in an arrow function. Regular functions can be passed in. However, an arrow function is less code to write. Whenever possible, I prefer to use arrow functions to write less code. Inside this function, we have complete freedom over what happens during an update. Before writing the logic, we must provide the data that should be watched. The second argument for the useEffect function is an array of dependencies. This array can contain a list of variables. These variables will be watched by the useEffect function. If a variable from the list gets updated, the function passed into the first argument will get executed. For this example, we are trying to store the count variable in the local storage API. Let's add the count variable to the array. Next, we can begin updating the storage. Inside the function, run the following function: local storage.setItem. The local storage object is defined by the browser. It's automatically available to us. On this object, we have various methods for interacting with the local storage. A new value can be added to the storage by calling the setItem function. It has two arguments. The first argument is a name for the item. Let's set the name to count. The second argument is the value that should be stored. Let's pass in the count variable. Keep in mind, this function will run after the count variable has been updated. We are guaranteed to store the latest value. Let's try testing our code. On the page, click on the link. As we do so, the count should continue to be functional. The question is, how can we check the storage? The Chrome Developer Tools has a panel for viewing this information. Open the Developer Tools for your browser. In Chrome, there's a panel called Application. Browsers have various APIs for storing data. Local storage is considered the simplest API. On the sidebar, we can find a section for the local storage feature. If we were to click on our app's URL, a table should appear on the right. Listed in the table is the count item. So far, so good. The next step is to check if the count item exists in the storage. If it does, we should set the initial value of the count state to the count from the local storage. Once again, we can utilize the useEffect function to achieve this behavior. Back in our script, let's add the useEffect function above the other useEffect function. There's another cool feature of the useEffect function. This function can run once if the array of dependencies is empty. Let's take a look by passing in an empty function and array. During the first render of a component, if the useEffect function does not have an array of dependencies, it'll be executed immediately. This can be a great way to set up a component after it has been rendered on the page. It's the perfect opportunity to check the local storage. Inside a conditional statement, we're going to check the local storage.getItem function. The getItem function will return an item from the local storage. We can specify the item by passing in the name as a string. Let's try grabbing the count item. Before updating the state, we should check the storage for the existence of the count. If the user is visiting our site for the first time, this item will not be available in their storage. It's always considered good practice to check the storage before grabbing an item. The getItem function will return the value or null. As we learned before, a conditional statement should have a Boolean value. However, behind the scenes, JavaScript will convert your values to Booleans for conditions. This behavior can be dangerous to play with. Generally, as long as a number is greater than 1 or a string has one character, the value will be converted to true. Null values are converted to false. We can safely assume that the block of code will execute if a value is found. Inside the block of code, let's run the setCount function. The name of the item will be called count. The value will be the local storage.getItemCount function. We're not finished yet. Local storage may store a different data type of our data. It may be possible that our number has been converted to a string. For extra assurance, let's wrap the getItem function with another function called parseInt. The parseInt function is defined by the JavaScript language. It'll convert a value to an integer. I run into problems with the local storage API. I always like to convert the data type before using it. Otherwise, we may get unpredictable behavior. Let's try testing our application. If we refresh the page, the count on the page should persist. We can refresh as many times as we'd like. Our application will keep track of the count. Awesome! We've successfully created a counter. This is the final React feature that we'll be learning. Future topics will be discussed as we explore Gutenberg. There are some additional topics that we'll need to get into before heading to the next section. Let's get into them.